Okay, a jetliner traveling northward is landing with a speed of 69 meters per second. Once the jet touches the ground, it has 750 meters of runway in which to reduce its speed to 6.1 meters per second. Compute the average acceleration. That is what we are asked to find. Magnitude and direction of the plane during landing. So let's draw our picture. We have the ground, and we're said that our speed is 69 meters per second right when we land. So, sorry, that's going to be our jet. I can't draw. So I'm going to call this V1. 69 meters per second is going to be V1. I will write our knowns right here. Okay, so, and we travel for 750 meters. This distance is 750 meters. And at that point, our velocity is no longer v1, it's now v2. And it's significantly slower, right? 6.1 meters per second. So for those who have been on planes, I think this is pretty, you can imagine this really easily. The reason why we would be slowing down is, remember, when v changes, that is always due to acceleration. So since we have different v velocity or speeds here, we know that there's a acceleration at play causing it to slow down. We want to find that acceleration. So let's think about what equations might be useful here. I am thinking of all the kinematics equation. So V final equals V initial plus the time you accelerated. So that's one. The distance you travel equals the initial, how long you travel with the initial velocity plus half of acceleration and time squared. The third one is V final squared subtracted by V initial squared equals 2ax. And I will number these. I think these are all that we will need. So now I'm going to try and solve. We are asked to find acceleration. We have acceleration in all of these equations. So let's just look at the first one, V final. So this is going to be like our final state, right? And this is our initial. So do we know the velocity at the final? We do. That was V2. Vi, that was our initial velocity. We also know that. We're asked to find acceleration. Now, do we know the time at which this jet traveled for from in the initial position to the final? We don't know that. So we can't use number one. Number two, the distance or the displacement, x, that is this, right? 750 meters. This is how much we traveled between initial and final. V initial we know, T we don't know. Okay. Number three, V final we do know, V initial we do know. Acceleration, that is what we are looking for, and x is the displacement. So I think we can use number three. I'm going to rewrite the equation. V2 squared minus V1 squared equals 2ax. We want to solve for a, So I'm going to divide both sides by 2x. Equals a. Now I'm just going to flip it so it looks like a equals this personal preference. And now let's put in our numbers. V2 was 6.1 squared minus V1 was 69 all over 2 times the distance we traveled was 750 meters. Okay, let's put that in our calculator. I think that should turn out to be negative 3.1 meters per second squared. So that should be our acceleration. And I want to point out the negative. Why is it negative? Well, I didn't do a very good job indicating that going right is our positive. But since this velocity, we're going right and it's a positive, so that kind of automatically set our right as positive. We are slowing down from our initial to final. To slow down, our acceleration needs to be moving to the opposite way. Kind of think like wind resistance or something. Like we have something pushing us back to make us slow down. So I hope that negative makes sense for you guys. And that should be our answer.